Coming on today's topic, so the photonics metrology system, I would like to start with an analysis of the current situation of the metrology market that is experiences, as you can see on the data that I've shared on my screen, a strong growth in these years and also for the next decade. Several reports estimate a growth rate from 4.8 to 7% in the next 5 years. And the valuation approximately of this market is indicated as in a delta between $5 and $9 billion, depending, of course, on market definition, hardware, software, services, and so on. And the growth reflected the increasing demand for metrology in many markets, also where Tecnottica is involved, which could be identified as key markets, key drivers of this topic. The automotive, for example, due to the huge expansion of electrical car marketing, the e-mobility and electric vehicles battery, the aerospace for contactless maintenance operation, the medical for the miniaturization of medical implants and medical solution, electronics and energy market for sub-nanometer precision requirements in the field of semiconductors, and at least the industrial one, so for the integration optical sensor in smart factory, automation system, industry 4.0, and real-time quality control are just a few examples of these markets' needs. Out of the markets where we can identify the growth I was talking about, it's also reflected into the technology innovation, always on some key drivers I have listed. So, for example, in the laser technologies, where advancement enabling higher accuracy and faster measurement speeds, the integration of AI and machine learning that is very common nowadays for automated data analysis, defect detection, and error correction. A portable, miniaturized, and compact instrument for in-site measurements and real-time process monitoring, and in multi-sensor integration, so combining optical technique with other types of measurement, for example, on contact sensor, 3D models, robotic system, in order to obtain more comprehensive information for all of the users of these technologies. So, after we have analyzed markets and all the technologies related identified as key drivers, here comes the challenges we have to face as a part of this world. The first of all is the factory that is not a laboratory. So since most of the time all the environmental conditions are not the one we could reach, for example, in a dedicated metrological lab, we have to consider flow vibration, temperature drift, and dust. And all of these raise measurement uncertainty are all factors that we have to consider while we are performing all of this processing. We need a fast error compensation and a quick recalibration on the instruments. All of these to give the market the best quality available for the results that we can obtain out of these processes. Second one is that the optical specifications are a complex topic. When you talk about spheres, freeform, diffractive optics, surface quality, and texture, we must follow up ISO 10110 rules that luckily is here to regulate all of these topics and make us possible to speak the same language, let me say. Otherwise, all the results are not acceptable and also, I would say, usable for all the users of this world. Third main challenge is that a lot of cross-functional skills are required in order to participate into these processes, because you have to talk about integrating hardware, software, different technologies, and all of that are interdisciplinary metrologic, robotics, analytic skills just to obtain results to the metrological processes. That last market data we perform, we make, needs to be usable. There is a high volume of data and defect analysis that must flow easily into sensor, ERP, but also into people. So this data needs to be easy to access for all the users. And coming from the situation I've just described, the obvious question is how can we face these challenges as an optical manufacturing company? So coming to the first one, that from my opinion is the main, since again we are an optical manufacturing company, is that our factory cannot be a lab. So we have to take into consideration some point in order to align as much as possible to a lab condition. So factory can isolate and enclose, for example, with granite-based floor and other techniques, the instrument into specific areas, or add light, thermal control, and clean air flow to cut out dust and draft and all of this noise into our meteorological results. Luckily, software compensation on the instrument can apply a compensation again on temperature and vibration condition, for example. That's also a huge help. Robots can place and multi-view rotation can be applied during these processes and can remove non-value movements and keep the repeatability of these processes. Another things can be that real-time 3D surface measurement device can become in line to the real data specification thanks to sensor with an advanced focus variation, for example, and can be used directly during the production process, but only also on the inspection. And at last, optomechanical system with kinematic mounts, for example, using a repeatable clamping force or auto-centering device, can reduce the variance up to the performance of a meteorological test. Again, coming to the challenges, I have mentioned before the standards. So, for example, what comes out from the ISO 10110, that is the main quality standard applied for the identification, characterization of tolerances, scratches, cavities, stains, bubbles, any kind of defects that we can occur on an optical surfaces, for example, talking about our cases. These specifications are described by various quality standards, which also list the method for the identification, the characterization itself of all of these defects. And thanks to them, again, I already said it, we can regulate and talk and speak the same language while we are challenging this topic. Cross-functional skills are required, so we need to have a team in our cases for our production where people are placed at first. So speaking about training, experting, and problem-solving skills, training is essential to face market challenges, and we need to be aligned year by year with the requirements and what's upcoming new from the market. The expertise on metrology, optomechanics, software data, and dashboard are encouraged, in our case, with several cross-training experiences. And the problem-solve aptitude is not something that we can learn, but start from the defect and its analysis. One standard method, fast learn, test small, and speaking numbers can create an outcome clear and usable for all the users of that. So, considering all of these challenges and all the points I've described coming from the market, that's a brief list of our metrology department. Where speaking about capabilities, we are able to offer interferometrical measurements on plano and spherical surfaces, EFL measurement up to 546 nanometers of length, and on-axis MTF measurements again up to at 546 nanometers length. We can also perform measurement on centering error and tilt measurement on plano and spherical optics. Any kind of angular or geometrical measurement, commonly like angles, radii, diameter, thickness, and so on. Toughness measurements on white light interferometrical technology, and cosmetic defects evaluation under microscopic camera and software analysis, evaluation, and measurement. To follow all of that, we have a team of 7 people constantly undergoing continuous training and constantly also coming from the factory tasks from introduction of new equipment and new technology and methods to follow all of this. That's why, since all of these needs, Tecnottica has a huge focus on future investment and new addition to our metrological sites, and there are constantly under process and under new addition. For example, already this year we have performed acquisition of a new high precision optical measurement system with the LufoScan 420 HD that basically is a non-contact profilometer that not only allows us to reach a higher value of clear aperture, so up to 420 millimeters in diameter, but also increase our capabilities in terms of shapes. So, for example, for spherical surfaces, to have real-time data to submit to our customers or to any kind of end users. And also, other two additions we had this year for system and metrology are new 6 inches interferometer, vertical interferometer, and the CM114 that it's basically a centering error and measurement system. Talking about next year's, as we have analyzed all the problem that came to having a manufacturing environment, we have a deep focus on create a new fine optics department with, of course, specific machinery and metrology, but mainly with a dedicated metrological lab, full equipped for any kind of testing service, where we will want to put temperature and humidity control environment and anti-vibration floor. So in order to avoid all the factors that concur to have any kind of uncertainty during the metrological process. We will have also an ISO 7 room for optical inspection activities, and a new dedicated machinery for production, of course. But the main topic behind our next expansion will be to increase the quality of the environment where we have to perform all of these activities in order to keep all the results we obtain as reliable and realistic as possible for all the end users. So again, thank you for your attention and the possibility from EPIC. In case you have any specific question related to what I have just described, please feel free to ask.